Assalamualaikum and hi everyone. Today topic is about validity. So when you have a scale and measurement, the next step is to test whether the scale and measurement is reliable and valid. Okay, so in the previous video, I already mentioned about the reliability. Okay, so in this topic, I will highlight on the validity. Okay, so what is the meaning of validity here? Validity is defined as the extent to which the instrument measures what it claims to measure. Or in other words, we want to determine whether the item we construct in the questionnaire be able to measure the dimension or not. Okay, or be able to measure the construct or not. So that is the validity. Okay, so let's say you have 5 items to measure the level of depression. So these 5 items, is it really measure the level of depression or not? Okay, so if it can measure the level of depression, so we can say that the 5 items is valid. Okay, so how to test the validity of the item? Okay, so first, we can use the content validity. So in the content validity, the content of instrument assessed by experts who familiar with the construct of interest. Okay, for example, let's say you want to study about the level of depression. So there are certain items, that can be construct that measure the level of depression. Okay, you can ask the psychiatrist or doctors to check your instrument, the item, whether the item that you construct be able to measure the dimension that you want to measure or not. Okay. Or you can also use face validity. Okay, for face validity, the non-expert judgment of individuals completing the instrument. Okay, you can distribute your questionnaire, to anybody, using convenient sampling, and then you can ask them, whether they understand or not the question that you ask. Whether they really understand or not. The requirement based on the questionnaire that you ask. Okay, so if they do not understand the questionnaire, so there's a possibility that the instrument or the item is not valid. It doesn't really measure what you want to measure. Okay. And then, you can also use a criterion validity. Criterion validity is the ability to predict some outcome or estimate the existence of some current condition. The criterion judged are based on the following qualities. So in terms of relevant, freedom from bias, reliability, and the availability. Okay. And then you can also use construct validity, to test the validity of the instrument. Construct validity is the most complex and abstract, because you must know the theory, and then the measuring instrument being used. So to develop the theory, you must read a lot and literature review and do literature review. And so that you can come up with the item that can measure the dimension that you want to measure. Construct validity is the degree to which score on a test can be accounted for by the explanatory construct of a sound theory. So let a multi-scale is developed to measure the tendency to purchase prestige brands. So multi-item scale. So the theory suggests that this tendency is caused by these three variables. So first, low self-focus, high need for status and high materialism. Further, we believe that tendency to purchase prestige brands is unrelated to brand loyalty, okay, and the tendency to purchase new product. And then the evidence of construct validity will exist, okay, if our scale correlates highly with other measures of prestige brand preference, okay, such as reported purchases and classification by friends, okay. So if it's correlate, so we call it as a convergent validity, okay. If it has a low correlation, okay, with the unrelated construct brand loyalty and tendency to purchase new product, so this is what we call as a discriminant validity. So in a discriminant validity, or the items, okay, will be classified according to the category, and then they are unrelated based on the category that have been discriminated. Okay, so to do the validity test, okay, so we can do the factor analysis. Okay, so the factor analysis can be done using SPSS. The purpose of conducting the factor analysis is to reduce or summarize a large set of variables using a smaller set of factors or components by looking for groups among the intercorrelation of a set of variables. Okay, for example, let's say you have 100 items, okay, to measure the level of depression. Okay, so actually you can reduce, okay, this large set of variable, okay, into a several component, okay, into a several groups, and then you can see that among these items are interrelated or not. Okay, the requirement to do the factor analysis, okay, the scale must be at least interval. Okay, however, in social science research, Likert scale 1 to 5 are often used. Okay, so later on I will demonstrate to you on how to do the factor analysis using SPSS, okay, for Likert scale data type. Okay, so these are the steps involved in factor analysis. Okay, first you need to assess the suitability of the data for factor analysis. Okay, and then you do the factor extraction, and then after that you do the factor rotation and interpretation. Okay, so step 1, okay, assessment of the suitability of the data for factor analysis. In terms of sample size, if you want to do factor analysis, okay, must not less than 50. Okay, preferably greater than 100 for every 20 cases or variable. Okay, so let's say if you have 20 items, okay, so you must have at least 100 respondent or 100 observation. And then for the intercorrelation, okay, when you run the correlation matrix, okay, you can look for the multicollinearity lah. Okay, so if the R greater than 0.8, so meaning that the item are highly correlated. Okay, so in this case we want the item to be uncorrelated, so that the determinant should be greater than 0.00001. Okay, so to indicate that there is no multicollinearity. Okay, and then we can also assess the suitability of the data by referring to the anti-image correlation matrix. Okay, so the anti-image correlation matrix assess the sampling adequacy of each variable. Okay, so it will appear in a correlation matrix. So if the correlation less than 0.5, so it is inadequate. So you can consider to exclude the variable, okay, for the item from the factor analysis. And then you can also use the Kaiser-Meyer-Okin or KMO. This KMO measure degree of intercorrelation among variables. Okay, and then the value of KMO range between 0 to 1. Okay, if the KMO is greater than 0.5, is considered as acceptable. And then you can also refer to the Bartlett test of sphericity. Okay, indicate whether the correlation matrix is an identity matrix. Okay, so for the Bartlett test sphericity, the value must be large and significant, okay, to conclude that the data is suitable for factor analysis. Okay, and then for step 2, okay, you do the factor extraction. For factor extraction, there are 3 methods. Okay, it's either use Kaiser's criterion, okay, script plot, or parallel analysis. Okay, but the most common technique are Kaiser criterion and the script plot. Okay, for the Kaiser's criterion, okay, the factors are retained if the eigenvalues greater than 1. Okay. While for script plot, use point of inflection. Okay, so find out at which the shape of the curve change direction and become horizontal. Okay, and then the retained factors above elbow. Okay, if the line, okay, below the elbow, so we can ignore the factors, or we can retain the factors, the item, okay, which are above the elbow. Okay, and then for the parallel analysis, compare the eigenvalue, okay, from factor analysis and simulation using Monte Carlo. Okay, so this is more to the simulation analysis. Okay, but the most common in factor analysis is these 2 criterion, Kaiser's and the script plot. Okay, so if you want to use a Kaiser criterion, okay, we use the Kaiser's criterion when less than 30 variables and commonalities after extraction greater than 0.7. Okay, or the sample size greater than 250 and mean commonality greater than 0.6. Okay, and then we use the script plot if the sample size greater than 250. Okay, or else you cannot really see clearly, okay, using the script plot the factor that should be retained in our research. And then after that, okay, is the factor rotation. Okay, so there are 2 types of rotation, orthogonal and oblique. Okay, for orthogonal there are 3 types: varimax, quatermax, and equimax. Okay, so where in the orthogonal, the assumptions underlying factors are independent or uncorrelated. Okay, for orthogonal, they are easier to interpret. Okay, and then most commonly used is a varimax. While oblique, okay, there are 2 types: direct oblique mean and promax, where the assumptions underlying factors are correlated. And then most commonly used, okay, direct oblique mean. Okay, so factor rotation and interpretation. Okay, if the factor loading, okay, 0.722, sample size needed is equal to 50. Okay, and then if the factor loading 0.512, the sample size needed is 100. Okay, so as you can see that as the number of sample size increase, the factor loading reduce. Okay, so you must be very careful with the factor loading here. For demonstration on factor analysis, I will use the online shopping habits data. Okay, so this is the example of the questionnaire, okay, that I construct to measure the online shopping habits. Okay, so there are 14 items, okay, that measure the online shopping habits. Okay, and then the rest are more to the descriptive analysis. Okay, so based on this 14 item, okay, I want to determine the reliability and the validity of the items, whether is it measure or not what I want to measure, okay, which is the online shopping habits. Okay, so I distribute this questionnaire to my previous students, okay, during MCO. Okay, I want to see their habits, okay, their online shopping habits during MCO. Okay, so this is the responses. Okay, so there are 42 responses, and then I can download the responses, okay, in the Excel file here. Okay, and then I transfer everything, okay, to the SPSS. Okay, but I do some amendment here. Okay, so S1, S2, S3 until S14. Okay, or else actually it will appear as the name of the variable here. So it is too long. So what I did here, I just make it simplify. Okay, this is S1, S2, and then the description I put under label. Okay, so there are 14 items, okay, that measure the online shopping habit. Okay, so I want to do the factor analysis, okay, because actually when I run the reliability, okay, remember if when I run the reliability analysis previously, I get the value of Cromba alpha less than 0.7. Okay, so we can suggest to do the factor analysis. Okay, so to do the factor analysis, okay, so you can go to the analyze. Okay, so remember, this is the Likert scale, S1 until S14. Okay, let me show you the data values, S1 to S14. So, this is the data values. Okay, so you can see that there are 5 category, okay, Likert scale. Okay, so I want to do the factor analysis on this 14 item. Okay, so how to do that? You can go to the analyze, okay, and then choose data reduction, dimension reduction, okay, and then choose factor. Okay, and then you can add all the 15 items, okay, to the variables here. Okay, and then after that, okay, you can click description. Okay, so under description, you click coefficient, okay, the significant levels, the determinant, the KMO, and the anti-image. Okay, so this is to test the adequacy of the data, whether is it suitable or not, okay, to do the factor analysis. Continue. Okay, and then you can click to the extraction. Okay, so the method that we use here, actually there are many methods. Okay, in this case, I use the principal component. Okay, so we analyze the correlation matrix, and then I want to display the unrotated factor solution and also the script plot. Okay, and then extract based on the eigenvalue. Okay, eigenvalue is greater than 1. Okay, actually if you have in your mind, okay, the number of factors to be extract, okay, you can click here and then decide the number of factors. Okay, if not, okay, you let the factor analysis to determine how many factors are retained based on the eigen value. Okay, you can click continue. Okay, and then for the rotation, okay, so you can use click Varimax. Okay, we try the Varimax, the orthogonal. Okay, continue, and then you can go to the options. Okay, you can sort it by size. Okay, and then suppress small coefficient. Okay, so we try to remove, or not to remove, not the coefficient which is less than the certain value not to be appear. Okay, so in this case, okay, let's say we let everything to be appear. Okay, and then later on we decide, okay, whether to suppress the small coefficients or not. Okay, you can click continue. Okay, and then okay. Okay, so this is the correlation matrix. Okay, and the significant. Okay, so what you need to interpret here is the correlation coefficient. Okay, the correlation coefficient here all, okay, less than 0.8. Okay, and then the significant value less than 0.05. Okay, and then you can refer to the determinant. Okay, so the determinant is 0.003, which is greater than 0.00001. Okay, remember, if the determinant is greater than 0.0001, so it's indicate that there is no multicollinearity problem. Okay, and then we refer to the KMO. Okay, the Bartlett test here. Okay, so based on the Bartlett test, okay, we get the chi-squared value 151.183 here. Okay, and then it is significant. Okay, so we can say that the sample is adequate. Okay, is highly significant. Okay, and indicate that the correlation matrix is not an identity matrix. Okay, and then okay, the measures of sampling adequacy here. Okay, we refer to the anti-image correlation. Okay, so all greater than 0.5, okay, indicates that variable should be included in the factor analysis. Okay, so let's say if there is if the MSA, okay, less than 0.5, the item should be excluded. So in this case, all of the items, okay, the correlation greater than 0.5. Okay, so all of them should be included, okay, in the analysis. Okay, and then remember the KMO, the Kaiser-Meyer-Olkin measure, okay, must be greater than 0.5. Okay, so in this case, the KMO value greater than 0.53, 0.5, which is 0.535. So indicates that the factor analysis is appropriate for this data. Okay, and then okay, we refer to this table of commonalities. Okay, commonalities before extraction. Okay, the initial is equal to 1. Okay, so because the principal component assume that all variance is equal to 1. Okay, and then after extraction, okay, 80% of the variation is associated with shopping on internet save time. Okay, so kita tengok ni. Okay, extraction, after extraction dia jadi 0.8. Okay, this one after extraction it becomes 0.696. Okay, so it means that the 0.8 indicate that after extraction 80% of the variance is associated with shopping on internet save times. Okay, and then okay, this table, okay, the total variance explained, okay, will determine how many factors are retained. Okay, so we refer to the Kaiser criterion. Okay, based on the Kaiser's criterion, okay, we use the eigenvalue greater than 1. Okay, so this is the eigenvalue. Okay, so there are 5 component which are the eigenvalue greater than 1. So we can say that there are 5 factors. Okay, and then the 5 factors, okay, explain 71% of the total variance. Okay, so kita tengok cumulative lah dekat sini. Okay, yang the last component, okay, where the eigenvalue greater than 1 is here. Okay, so there are 5 component. Okay, so the cumulative percentage is 71%. So the 5 factors ni, 1, 2, 3, 4, 5, these 5 factors explain, okay, 71% of total variance. Okay, and then you can also use the script plot, okay, to support the number of factors should be retained. Okay, so actually this is the eigenvalue. Okay, so you tengok dekat sini lah, actually this is what we call as the elbow. Okay, so if the point, okay, below the eigenvalue equal to 1, okay, this one can be ignored. Okay, so kita ambil point yang above 1 lah. Okay, so 1, 2, 3, 4, 5. So there are 5 factors should be remain. Okay, in the should be retained. Okay, so therefore the results is similar as using the Kaiser criterion. Okay, and then after that, okay, we go to the rotated component matrix. Okay, so as you can see that, okay, we let all the coefficient to be appear here, so it's very difficult to read which item falls on which category. Okay, but we use, okay, we refer to the highest correlation here. Okay, so for example here, okay, so for item while shopping online, I hesitate to give my credit card number. Okay, so in this case, okay, the this item, the highest correlation is on component 1. Okay, so while shopping online, I hesitate to give my credit card number should be under component 1. Okay, or else what you can do here, okay, you can rerun the factor analysis. You can remember the option part, suppress small coefficients. Okay, so let's say in this case I want to suppress, okay, absolute value below 0.5. Okay, continue and okay. Okay, so I can see that, okay, for component 1, so these are the item. Okay, component 2, these are the item. Okay, and then this component might be eliminated, okay, because the coefficient less than 0.5. Okay, this belong to coefficient belong to component 3, this 2 component 4, and then these 3 belong to component 5. So basically from the rotated component matrix, okay, so you can discriminate or classify the items according to groups. Okay, so for example here, okay, for factor 1, there are 4 items, okay, are being in a group, okay, so which is which are S11, okay, S7, S6 and S14. Okay, so the items are, while shopping online, I hesitate to give my credit card number. Selection of goods available on internet is very broad. A long time is required for delivery of product and services. I prefer cash on delivery than payment via credit or debit card. Okay, so this factor, okay, I can name it as a convenience. Okay, and then the second factor, okay, there are 2 items, okay, which are S8 and S9. Okay, so S8, the item is the description of product shown on the website are very accurate, and then the information given about the product shown the websites are very accurate. Okay, so this is about the informative. Okay, so factors of the online shopping habits can be discriminate into a group of informative. Okay, and then the third factor, okay, is about time. Okay, so shopping on internet save times. It is a great advantage to be able to shop at any time of the day. Okay, so in neither online shopping habit, okay, because of the factor is because of the time. Okay, and then factor 4, the necessity of having bank account or credit card creates difficulty. And then internet reduce the monetary cost of traditional shopping. So S12 and S13 both are in one factor. Okay, and then the last factor, online shopping will eventually supersede traditional shopping. Okay, online shopping is as secure as traditional shopping, and then online shopping is risky. Okay, so the fifth factor is a security. Okay, so based on this group, okay, of factors, okay, so you can do you can create, okay, a score. Okay, so for example, factor 1, okay, represent convenience. Factor 2 represent informative. Okay, 2 items that measured pertaining to the informative. Okay, the third factor is about time. Okay, the fourth factor is cost, and then the fifth factor is security. Okay, and then, okay, if you want to test, okay, or to check whether the varimax rotation is appropriate or not, okay, you see the correlation value. Okay, so if the correlation among the component are low, okay, so you can say that, okay, the varimax rotation is appropriate. Okay, so how to report the factor analysis? Okay, a factor analysis was conducted on 14 items, okay, with varimax rotation, and then you report the KMO. Okay, the KMO measure verified the sampling adequacy for the analysis. Okay, in this case, you get the KMO equal to 0.535, which is greater than 0.5, and then the Bartlett test of sphericity, okay, is sufficiently large, okay, 151.183, and highly significant, that indicate that, okay, the correlation between items are sufficiently large for factor analysis. Okay, and then an initial analysis was run to obtain eigenvalue for each component in the data. And then 5 components had eigenvalue over Kaiser's criterion and explain 71% of the variance, okay, based on the output that I just show you. Okay, and then the script part supported the Kaiser's criterion that there are 5 components. Okay, And then after you run the factor analysis, okay, you can perform the reliability analysis for each construct for measuring consistency. Okay, so for example, remember, okay, when I run the overall reliability analysis, okay, analyze, and then after that scale, and then I choose the reliability analysis. Okay, I will get, okay, the Cromba alpha equal to 0.6, okay, equal to 0.685, okay, which is less than 0.7. Okay, so it's a moderate reliable. Okay, so I get the reliability, the Cromba alpha equal to 0.658. Okay, so therefore it is necessary, okay, to do the factor analysis. Okay, so based on the factor analysis, okay, remember, okay, so the first factor, so these are the item, okay, that's supposed to be in factor 1. Okay, so which are, let me go back to the previous slide. Okay, so which is item number 11, 7, 6 and 14. Okay, so how to do that? Okay, so I just go to the SPSS, okay, choose analyze, okay, and then go to the scale, scale reliability analysis. Okay, so now, okay, instead of taking all of the items, so we choose only item number 11, 7, 6 and 14. Okay, 6, 7, 11, okay, and 14. Okay, and then click OK. So as you can see that, okay, so the reliability of the 4 items, okay, is equal to 0.689. Okay, slightly higher compared to taking all items, okay, to be measured. Okay, and then let's say we see the second item, or the second factor. Okay, so for informative, we have item number 8 and item number 9. Okay, so we can go to the analyze, scale, okay, reliability. Okay, so we remove all this. Okay, and then we choose item number 8 and item number 9. Okay, so we can see that the Cromba alpha 0.851. Okay, so it's very high, okay, greater than 0.7. So these two items, okay, can measure, okay, the factor number 2, okay, which is about the information. Okay, so you can run, okay, the reliability analysis for factor 3, okay, factor 4 and factor 5. Okay, and then after that, after you get the reliability, and after you do the reliability analysis, and if they are reliable, the next thing you can do is, okay, you can compute the score. Okay, so for example here, okay, let's say for factor 1, so these are the 4 items, okay, that measure factor 1, which is about the convenience. Okay, so what you can do here, okay, you can go to the transform, compute variable. Okay, so let's say you can give the name of the new variable as a convenience. Okay, so let's say I use the mean value. Okay, or you can go to the function group. Okay, so statistical, so I want to find the value of mean. Okay, so mean of the item number 11. Okay, and then item number 7. Okay, and then item number 6, and finally item number 14. Okay, and then I just click OK. And then if you go to the data view, okay, you can see that there is one variable that named as a convenience. Okay, so this variable will measure the dimension of the convenience. Okay, and then you can also do for factor 2. Okay, so for factor 2 there are two items, S8 and S9. Okay, so you can go to the transform, compute variable. Okay, so let's say the second factor, the variable name is informative, so you put here informative. Okay, let's say you want to compute the mean for S8 and S9, so I put here S8 and S9. Okay, and then just click OK. So if I go to the data view, so I can get the score, or the average score, for the dimension of informative. Okay, so you can try to compute the mean for factor 3, factor 4 and factor 5. Okay, and then later on I will show you on how to make use all this information in a quantitative data analysis. Okay, thank you.